Hello, everyone. We meet yet again, once again to discuss Newton's laws. Now, if you missed the first lesson, please just go a step back. We started on Newton's laws, and I expanded a little bit on the definitions. If you haven't subscribed to my channel yet, please make sure that you subscribe. And by the way, if you need to, send me a question, or if you've got any queries, just throw in at the comments, or you can send to my personal email. It's Mlungisi, Mlungisi .m.nkosi.co. So it's mlungisi.m.nkosi@gmail.com. All right, now let's get to it. Today I want to talk about pulleys. All right, so essentially on Newton's laws, what happens when we've got pulleys that are acting on a system? What exactly is a pulley? So essentially a pulley is a wheel that is able to turn. So just imagine this wheel that can turn, all right, and we put a string around it, okay? And let's just say, for argument's sake, we've got a mess here, and we've got, say, another mess there, okay? Right, so essentially, if you've got a system like that, imagine this is a wheel that can turn. Now, when we talk about pulleys, we normally talk about pulleys that are okay. Right, so we talk about pulleys that are frictionless. So that simply means that the pulleys that we are going to actually look at are pulleys that are frictionless. So what does that mean if it's a frictionless pulley? So essentially what it simply means is that the tension on the one side of the pulley should be equal to the tension on the other side of the pulley, meaning that there's nothing that will change the force exerted on the one side of the pulley to the force on the other side. Okay, so I want us to quickly look at this question. Suppose we've got a 10 kilogram block, and then we've got another 5 kilogram block. Okay, right, what should essentially happen here? Of course, we know our pulley can turn around. Okay, so we said yesterday, suppose we want to find out what the acceleration of the system is. So let's find out what the acceleration, and then secondly, let's calculate what the tension on that system will be, right? So first of all, let's just predict what's going to happen. What do you think is going to happen in this particular system? All right, yeah, I think you've guessed it. So essentially, because the 10 kilogram mass, right, has a bigger gravitational pull on it, okay, so it has a bigger gravitational pull on it. So in this case, the bigger, obviously both of them are being pulled due to gravity, isn't it? So in this case, because this one has got a bigger gravitational pull on it, all right, it will the system will tend to actually go in the direction of the 10 kg. So essentially this one goes down, okay? And if it goes down, then it means that this one essentially is pulled upwards. Now, how do we tackle these kind of questions? Okay, so essentially what we're going to do is we're going to choose a positive direction for each of the blocks of mass, right? Now, if you think about this one, I'm going to just simply say it means turning that direction is positive. Now, I want you to think about it. I always take direction of motion as positive. Now look at this. It means this block is going down, okay? So I'm going to take, for this one, it means downwards is positive. So it means downwards is positive. Now think about this on this one. What's happening to this block? Okay, right, it's going upwards, right? So for this block, for the 5 kg block, I'm going to accept that upwards is positive. Why? Because it would be moving upwards on the system. Okay, so now let's try and draw our free body diagrams. Okay, I'm going to draw the free body diagram for the 10 kg block, right? So what do I have? I know it's acting, gravitational force is acting on it, right? Remember in our previous video we said, how do you calculate gravity? You say mass times gravitational acceleration. So for this one, it's going to be 10 multiplied by 9.8, and that's going to be 98 newtons. Okay, just gonna lift that a little bit. Right, so that's 98 newtons of force. So essentially, so this as it is being pulled down, what other force is acting on it? Yes, you guessed it. It's going to be the tension on that string, isn't it? Now think about it. If you didn't have it tied to that rope, it would actually still be moving down, but it would move down on its own, right? And essentially it would be accelerating downwards due to gravitational acceleration, or due to gravitational force, and it would accelerate much faster. So essentially on this 10 kg block, right, what is this tension doing to this guy, right? So you'd imagine that yes, it would still be going down, but it would actually be moving down slower than it normally would if it wasn't tied to that rope. So yes, so it means that the tension there is essentially exerting a force that is upwards, okay, an upwards force. So essentially, now if you look at the magnitudes of my force, all right, you can clearly see that this one is bigger, all right, this is for the 10 kg, right? So this force is essentially bigger than this one. That's why essentially this system, or rather this block, is actually moving downwards. Okay, so now I'm going to generate an equation for it. Okay, I'm going to say, all right, for this guy, for the 10 kg block, okay, what do I have? I know that F net is equals to MA, okay, right? But what is my F net value, or rather what are my forces? What is the net force? What is the net force rather? It's the sum of forces in the vertical direction. I'm only looking at the vertical motion here, right? So sum of my vertical forces is equals to MA, right? So now we've taken downwards as positive for this guy. So I know that it's going to be the force of gravity, which is positive, right? And we are adding, this means sum of, right? So we are adding, but what are we adding? The tension force, isn't it? But remember, the tension in this 10 kg block is actually pulling upwards, right? It's actually slowing it down. So as a result, it's a negative force. It's in the opposite direction. So this gives us the mass multiplied by the acceleration. And of course, once again, so that's 98 minus t. This is going to be equal to 10a. Okay, so essentially this is going to be our equation 1, right? Now then we look at this 5 kg block, right? So we finished with the 10 kg. Now we're going to say, right, for the 5 kg block, now let's start with the free body diagram. What are the forces that are acting on the 5 kg block? You said to me, okay, the 5 kg block is going to go upwards, right? So essentially it means that there's a force that's pulling it up, okay? And which force is pulling it up? Now once again, what did we say? All right, sorry about that noise. Right, so we said in this case, when you look at a system like this, we've got a pulley there. So it means the tension on the one side should be equal to the tension on the other side. So the tension there is pulling the 5 kg upwards. Okay, right, so the tension is pulling the 5 kg upwards, but what is it acting against? It's acting against the force of gravity, which is essentially downwards. So this is force of gravity, this is mass times gravity, gravitational acceleration. That's 5 times 9.8, and that will give us 49 newtons. Right, now look at this. The tension is pulling it upwards, pulling the 5 kg up, but remember gravity is still acting on it, and it's always acting vertically downwards. Right, so now we're going to say, okay, this is now for the 5 kg block, okay, for the 5 kg mass. So essentially what it simply means is that F net is equals to ma once again, right? A Newton's second law of motion, right? As I did say, if you missed our first lesson, please just go back to it. It will show you how we actually applied this, right? So this is going to be, now remember we said for this guy we are taking upwards as positive. Remember we said this system, as you're looking at it, this is what's going to happen to it. As the 10 kg goes down, it pulls the 5 kg upwards. So you always take direction of motion as positive. So in this case, I'm going to simply say, all right, so this is going to be my tension. That is positive, right? Plus a negative gravitational force. Okay, or you can call it FG2. If you want to, you can call that FG1, FG2. Okay, this is equals to M2. Let's call it MS2, right? Okay, so that would have to be M1. Okay, so that's M2A. So that's tension minus what's the force of gravity? That's 49. Okay, this is equal to 5A. And that's essentially equation 2. Okay, right. So for those of you who followed on our first lesson, you know exactly what we did when we got to this stage, right? So what we simply did is that, of course, you can always solve this simultaneously and simply say, take the subject of t as the subject of the formula, substitute into the other equation. Nothing wrong with that. But I showed you a method wherein you can just simply take equation 1 plus equation 2, right? So it means that you're going to say 98 minus t, take everything that's on the left-hand side of the first equation, right? Plus, you are adding it to everything that's on the left-hand side of the second equation. That's 49, which is equals to, then you've got 10a plus 5a, which is 15a, right? So that's minus t plus t. I did show you that every time you use this method, you're always going to end up with one of your variables cancelling out, right? So essentially, so we're going to have 98 minus 49, right? So that gives us another 49 there, which is equals to 15a. And we are going to divide both sides by 15. Okay, right, so to get the value of a, and let's just grab our calculator quickly, right? And then so we have 49 divided by 15, and that's going to be 3.27 meters per second squared. Okay, right, meters per second squared. All right, so that's your answer for the acceleration. But now remember, we said we wanted not just the acceleration, but we wanted the acceleration as well as the tension, right? So now how do we get the tension? We're just simply going to say, okay, let's substitute for equation rather a, which is equals to 3.27 meters per second squared, right? Let's substitute it in, let's take the second equation, okay, in equation 2. So now what do you have? We're going to say t minus 49 is equals to 5 times our value for a, 3.27. Okay, because I still have this value as it is in the calculator, let me just multiply that by 5. Okay, and then and then just add, take that to the other side, plus 49, and essentially I get a value T is equals to 65.3 newtons. Okay, so I get a value of 65.3 newtons for the value of your tension. So essentially, the most important thing that I wanted to show you when it comes to pulleys is that, please note, we're always going to talk about frictionless pulleys. So what it essentially means is that the tension on the one side of the pulley is equal to the tension on the other side of the pulley. Now, what I want us to quickly do is to look at systems whereby you've got more than one block of mass, let's say, on the system, and you've got one moving in one dimension and the other in another dimension. So if you've got this, if you understand what we've done here, so there's our tension value there, the magnitude is 65.3, so you should be super. Now let's go to the next question. All right, so here's our overly simplified diagram. Okay, so suppose they give us a system like that. Again, we've got a pulley. Now it's going to pull. Okay, so they tell us that the system is accelerating downwards. Okay, don't worry, just in just a moment we'll just take past exam questions wherein you've got a long statement. So I don't want to overly complicate this what we're trying to achieve here. What I want to give you first is a method on how to approach the question, and then we can thereafter look at past exam questions. Okay, right, so now there it is, they're telling us that this system is accelerating. Okay, so it's accelerating in that direction. So now if we the other block of mass is actually sitting on a table, right? And if this table, the coefficient of kinetic friction on the table between the block and the table is 0.2, right? So what I would like for us to do is then determine the acceleration, okay? And I want us to calculate the tension. It's not like they will ask you that all the time, but as I'm going to show you, once you know how to approach the question, then you should be able to answer for any scenario that they might possibly give you. Okay, so please don't worry too much about that. Okay, so now I can hear some of you complaining, oh sir, but how can an 8 kg mass pull a 12 kg? Remember, when you're looking at this system, right, what is pulling this 8 kg block down? Remember, it's not the mass, it's the force of gravity. Okay, so the force of gravity in this case, what would be the value? So that's 8 times 9.8. Okay, so that's about 78 newtons of force that are pulling down, right? So if you think about this mass, however, okay, so you've got the force of gravity pulling it down, but at the same time you've got the normal force. The table is actually exerting a force upwards, right? So essentially at the end of the day, this weight, okay, this weight here will not necessarily play such a big role in the motion of the 12 kg block, right? Why is that? Because remember that the weight of this mass is actually now counteracted by the normal force, which is the force that the table exerts back on this mass. So essentially, what this force of gravity is acting against is just the frictional force on this guy. All right, so please, you can try it, by the way. Take a smaller mass and then take something that is bigger. Of course, it depends on the amount of friction that would be on that thing, but essentially it does work. Okay, right, now let's get into the question. So now we want to know, okay, so what are we going to do? We know that it's accelerating in that direction. So if this one is going down, right? So what will happen? As it goes down, remember, it starts pulling. We've got a pulley there, right? It starts pulling the 12 kg mass towards your right, isn't it? So in essence, I know this one is going down. So for this 8 kg block, downwards would be positive. Okay? And this one, obviously, it's being pulled towards your right. So in this case, for this guy, okay, going to the right is our positive direction. Okay, sorry, that's out of range a little bit. Okay, so for that guy, okay, going to the right is positive. Now, how do we approach? We're going to do essentially the very same thing. Okay, so what we've been doing before, we're going to simply say, all right, we're going to draw a free body diagram. Let's draw a free body diagram showing all the forces that are acting on the 12 kg mass. Now, do you agree with me? What is pulling this guy to move forward, to move to the right? Of course, it's going to be the tension acting on it, right? So the tension force, the tension on that string there. Oh, by the way, remember what I said to you in our last video, that we're going to always be talking about light inextensible strings, right? So the fact that they are light tells us that we don't consider the mass of the string. Secondly, they are inextensible, which simply means that it's not like you are dealing with a rubber band, right? So that means that the acceleration of this one should be the same as the acceleration on this one. Okay, the only difference will be obviously their direction of movement. Okay, so what are the forces? We said that's tension. That's going to be, now they told us there's a coefficient of kinetic friction. So now we know there's frictional force, and we said frictional force, it's the force that opposes the motion. So there's our kinetic friction there. But what other forces are acting on it? It's going to be the weight or gravitational force. Okay, remember I said if they asked you to draw a labeled free body diagram, you should actually write out the words in full there. So this should be force of friction, and then you see, now I actually messed up my own space. So what do we also have? We've got the normal force. Remember, the force, we said normal force is only applicable when something is actually sitting on a surface there, right? So now we've got the normal force right there. Okay, right, now this is essentially for the 12 kg mass. Okay, now I'm going to say let's generate an equation for this guy. Okay, but first we're going to need the value of friction, isn't it? But how do we calculate that value for the frictional force? We're going to say, okay, friction, we said friction is equals to coefficient of friction multiplied by the normal force. But how do we get our normal force? Now remember, what did we say in our previous video? We said, okay, in this case, I'm just going to write it out in brackets there. Because this block, the 12 kg mass, is not moving vertically. Can you see that? Because it's not moving vertically, it simply means that the forces in the vertical dimension are at equilibrium. So the sum of forces in the y direction for this guy, for the 12 kg, are equal to 0. Now what are those forces? It's going to be the normal force minus the force of gravity, right? In this case, those are your vertical forces. This is equal to 0. Okay, so therefore it means that normal force must therefore be equal to the gravitational force. And in this case, what would your gravitational force be? Right, you've got it quite correctly. So that's 12 times 9.8. Okay, so that's 12 times 9.8. So that's 12 times 9.8, and I get a value of 117.6, 117.6 newtons. Okay, right, now look at this. So we wanted to calculate the frictional force. So what did we just find now? The normal force, isn't it? So we found that the normal force is 117.6. So now all we're simply going to say, we are calculating friction. So frictional force will be the coefficient. Remember, our coefficient was given as 0.2 multiplied by that normal force, 117.6, okay, times 0.2, okay, and I get a value of 23.52 newtons. Okay, so that's our frictional force value. Right, now what did we want to do with that value? So now what we all that we wanted to do, we're now finding the acceleration. So this is for the 12 kg. Remember, where's the 12 kg mass moving? Right, we said it's moving horizontally, right? So what we're simply going to say is, okay, for the 12 kg mass, okay, for the 12 kg mass, we have, look at this now, the sum, or rather let's start with the Newton's second law. So F net is equals to ma. So I'm going to say, okay, the sum of my forces in the horizontal direction, right? Remember free body diagram, right? We're going to look at forces in the horizontal direction is equals to ma. And what are those forces? It's going to be tension. Remember we said going to the right is positive, right? So it's going to be tension plus, okay, right, let me just adjust my screen a little bit. Okay, yeah, let's take it there. Right, so we're going to say tension plus a negative frictional force. There's our friction there opposing the motion. Okay, and this is equal to ma. So this is tension minus, remember we got the frictional force value, that's 23.52, and this is, what's the mass? It's 12, and our acceleration is a. Now I'm sure some of you are actually beginning to see this. It's actually quite a repetition. We're just going to use the same approach over and over and over again. Now, for some of you who are a little bit more advanced, of course, I know that you can take all of this as just one system, right? Where you're going to look at the external forces that are acting on it. That would be gravitational force. That would be the friction acting here. And you can really combine those masses. Now, while I'm mindful of that approach, I also need to, just caution you on it that there are some instances where you are actually compelled to break it down into those different parts. So I would rather now teach you to be, in a consistent manner than, try to change the manner in which I approach things. Okay, so I'm gonna stick to this if that's okay with you. All right, now let's have a look at this. Now we've got our equation, so that's our equation 1. So where do I get my equation 2? You're quite right, we're going to get it from the 8 kg mass, right? So what are the forces acting on our 8 kg mass? Okay, so we know we've got gravitational force, or the weight. Okay, so let's say weight, that's pulling us down, mg, and this is going to be 8 times 9.8. Why do I think we have, okay, 9.8. Okay, 78.4 newtons, that's the exact amount. Okay, 78.4 newtons. And then what also do we have? Remember, if it was just moving on its own, what would be happening to the 8 kg block is that it would simply be moving much faster on its own. But in this case, what's happening? It's the tension that's actually kind of acting against it, right? Against the motion. So in this case, I'm showing you that weight is much bigger than the tension, right? So essentially, what do we now have? Now this is for the 8 kg block, okay? Right, so we know that F net is equals to MA, okay? That's Newton's second law. And all that there is to it is that the sum of forces, now notice for this one, it's only horizontal vertical forces that are acting. Sum of forces in the vertical dimension is equals to MA. So as a result, what are those forces? Now remember, I took downwards as positive for this mass. So it means that it's going to be the weight minus, by the way, I'm using W now for those of you who just prefer to use the word weight instead of force of gravity. So I'm just trying to accommodate everyone. So weight minus force of, the tension. So it's the weight going down, okay, because down is positive, minus the tension. Tension is going up. So that's weight minus tension. And this is equals to the mass, which is 8, okay, times the acceleration. Our weight there was 78.4 minus tension, and this is 8a, okay, and let's leave that as our equation 2. Alrighty, now I'm sure you've got it by now, right? What do we do? Where do we go from here? So we're simply going to say, okay, take equation 1 plus equation 2. And I did say, ladies and gents, this process or this procedure, as long as you've generated your equations in the correct manner, you'll always get to the right answer here. Okay, so we're going to have T minus 23.52, okay. Let me do this so that we can see that I'm actually at a different point. Okay, so that's going to be T minus 23.52 plus, okay, so remember it's this guy here, the left hand side of this equation, plus 78.4, okay, minus the tension. And what is this equal to? We add the right hand side, 12a plus 8a, and this will give us 20a. Okay, right, so that gives us 20a. Now notice you've got t minus t there. So what happens? You guessed it right. So you've got those t's cancelling each other out. So now you've got negative 23, right? So minus 23.52 plus 78.4, okay, and that gives us 54.88 is equal to 20a. Right, all that's left for us to do now is just divide both sides by 20. Okay, that cancels that, and your acceleration, so divide that by 20, and that should give us an acceleration of 2.744. Okay, I'm just going to round it off to 2 decimal places, so meters per second squared. Okay, so how do we get our value for tension? Okay, so you remember, what did we do? We just simply substitute for the acceleration in one of the equations. So whether you substitute into this one or you substitute into that one, you should be able to get to the correct answer, right? So I'm going to substitute into equation 1. In equation 1, okay, so I've got T minus 23.52 is equals to 12 times 2.74. If you want to say 744, because that's what we got in the first place. So that's times 12. Okay. And then remember 12 times that. And then if I take that to the other side, it becomes positive. So plus 23.52. So that's 56 rather, 0.45 newtons. That's the value for attention. So as I said, ladies and gents, so what I'm trying to do is just to show you, okay, I don't know if I can zoom that out a little bit. Okay, so what I'm trying to do is just show you how we handle questions where we've got, okay, something that is moving, or one of the blocks moving horizontally and another one moving vertically. So still the same thing. You just consider the direction of motion as positive for each block, and you just do what we've been doing all along. I hope this kind of makes sense, right? So what I want us to do next is I want us to try and tackle a past exam question. I'm sure some of you have been looking forward to that, and I'm going to show you still the same approach, right? Once you know what I've taught you, you should be able to answer those questions quite easily. Okay, right, now let's do that in just a few. All right, so here's a past exam question, okay, on Newton's laws. Right, so similar system like we had. We've got a pulley there. We've got a 2.5 kg mass. Now they say to us 2 blocks of mass M, right? So we've got mass M there, and 2.5 kilogram respectively. So that's the 2.5 kg. Are connected by a light inextensible string. Do you see that? Light inextensible string. Okay. I know some of you might not be able to see that very clearly. So it's a light inextensible string. So what do we mean when we say light inextensible? It means we disregard the mass of the string, and we do not consider as well, or by the way, it tells us that it's not an elastic string. So it means the tension on the one side, or rather it tells us that the acceleration should basically be the same. Right, and then they say the string runs over a light, frictionless. You see that word again, frictionless. So they're telling us it's a frictionless pulley. So it means the tension on the one side should be the same as the tension on the other side of the pulley. Right, as shown in the diagram, they say the blocks are stationary. That is very important. Now, if you remember in our previous video on Newton's laws, in our first one, we said once they tell us about something that is stationary or something that is moving at a constant speed, right? So what does that remind us of? Newton's first law. And remember, what does that Newton's what did Newton's first law actually state, right? That a body will remain at rest or in constant motion in a straight line unless it is acted upon by a non-zero resultant force. Okay, right, so now let's look at the question. Now so we know that the acceleration on the system should now be 0, right? So they say, first of all, state Newton's third law in words. Okay, remember Newton's third law says if body A exerts a force on body B, then body B will exert an equal but opposite force on body A, right? So that's what Newton's third law. Please, 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 ladies and gents, you must know how to state your laws, right? I really consider it as you know, just a way of the examiner just giving you free marks. Okay, just remember those laws. I'm reminded of Mufasa. Remember who you are, Simba. Right, so look at this. The first question, they say calculate the tension in the string, right? So now I'm going to shy away from that guy. Now think about it. Why do I want to shy away from it? Because I don't know what mass M is, but you see, again, I don't know what the tension on the string is. So I'd rather let me go and work with this 2.5 kilogram mass. Okay, so I'm simply going to say, okay, so here's a free body diagram showing me forces that are acting on that 2.5. So so it's going to be the force of gravity or the weight, that's mg. Okay, so this is telling me it's mass 2.5 times 9.8, and where did I put my calculator? There it is. Okay, so it's going to be 2.5 times 9.8. This is 24.5 newtons. Okay, right? But also what's acting against it? Remember, it's stationary, right? So it simply means that the tension is actually pulling this guy upwards. Otherwise, it would be going down, isn't it? And by the way, because it is stationary, it simply means those two forces are, you've got it right, are simply balanced. So in this case, it means that the net force is equal to, you guessed it right, it's equals to 0. Why? Because in this case, because it is stationary, it means the sum of forces that are acting on this will be equal to 0. So as a result, now I'm going to take downwards as positive, if you don't mind, right? So it means I'm going to say force of gravity minus the tension, that's going to be equal to 0. That's the sum of my vertical forces, right? So that's 24.5 minus T is 0. And so it means that T, if I take it to the other side, is equal to 24.5 newtons. And that makes sense, right? Because it means that the tension, the force acting downwards, should be equal to the force acting upwards, and that's why it is keeping that mass stationary. Okay, right. Okay, and then as our next question, they say all right, so they give us a statement first. They say the coefficient of static friction, you remember we said when something is stationary, then it means that static friction is acting on it, right? So the coefficient of static friction between the unknown mass m, right? Okay, and the surface on of the table is 0.2. So they give us the coefficient of friction, okay, and they also tell us that this is mass m. Now they say to you, calculate the minimum value of mass m that will prevent the blocks from moving. So we are still dealing with a situation where the block is stationary. So this was 5.1.2. Okay, we're looking for the tension, and then now we're looking at 5.1.3, right? Okay, so the minimum mass, minimum value of m. So now, first of all, before we go further, let's just first check what are the forces acting on mass m. Okay, so it's going to be the tension pulling it in that direction. It's going to be the friction opposing the motion. Remember, it's stationary, so it does tell you that those two forces that are acting horizontally are opposing each other. So that's tension there, that's friction, okay, and that's normal force, and that's gravitational force. So that's gravitational force there, okay. And remember, what is our gravitational force? It's going to be M, big M, multiplied by 9.8. So we're going to have 9.8 M, right? So now, and by the way, we know the sum of our vertical forces. What's our normal force? I think you already have seen this by now, that the normal force in this particular case should be equal to gravitational force, right? And therefore it's equal to 9.8 M, right? So now let's look at the horizontal force. Horizontally, you say F net is equals to MA, but that's the sum of our vertical forces, our horizontal forces. So that's the sum of forces in the horizontal direction. This is equals to MA, but we know that acceleration is 0. And why is it 0? Because our block is stationary. So it means that tension, so I'm going to take direction to the right as positive, right? I'm allowed in this case because it's not going anywhere, right? So tension minus, okay, so that's tension in the positive direction minus frictional force in the opposite direction, and this is equal to MA. Now, if you remember, okay, I'm just going to continue. Okay, let me try and create some space down there. Right now, in this case, so tension minus, now frictional force. How do we calculate friction? We said it's the coefficient of friction, and remember we're given that value to be 0.2, right? So it's going to be 0.2 multiplied by the normal force. What is our normal force value, right? Remember we said a normal force would be 9.8 M, and this is equal to what? Right, it's big M, but remember we said our acceleration is 0, so it should make this whole thing equal to 0. Now, I'm sure you've already noticed. I'm going to just continue on this side here. Right, we already know the value of T, right? We found it. It's 24.5, okay? And then, so we found the value of tension minus 0.2 times 9.8. So that whole calculation there. So 0.2 times 9.8, and that should give me 1. Okay, sorry about that. Okay, so that should give me 1.96 M. This is equal to 0. So all of this is equal to 0. Right, so take that to the other side. 24.5 equal to 1.96 M. Divide both sides by 1.96. Okay, so the value, the minimum value of M, 24.5, divide by 1.96. Okay, so M is 12.5 kilograms. Now, now look at this, ladies and gents. This mass is only 2.5 kilograms, but it's able to pull a 12.5 kilogram block. So essentially what I'm trying to say to you is that please don't be deceived by the fact that this is a smaller mass than that. You know, of course in this particular case it's stationary, but it really does not change anything much. It could as well have been moving. So if you just make that mass a little bit smaller, then the whole system therefore starts moving, right? I mean, just a little bit bigger, you know, just change it by a small amount. It would cause the system to start moving. Okay, right. So I hope that's clear for you. See, I'm trying to show you that we really have not changed much in terms of our manner of approach. Right, now I'm just going to cover that a little bit. Okay, right, the last question, they say calculate, so they give us a statement now. They say the block of unknown mass m is now replaced with a block of mass 5 kilogram. So then it means that they changed from this 12.5 kilogram here, but they put 5 kilograms instead, right? They say the 2.5 kilogram block now accelerates downwards. So they are telling us when we change this to 5, okay, it causes this guy to simply go down. Now let's create some space. So they've changed everything that we've done thus far. Okay, so remember, everything that we had calculated about this whole block now changes, right? They say that the block now accelerates downwards. Okay, so it's no longer stationary, so there is an acceleration. Okay, they say the coefficient of kinetic friction between the 5 kg block and the surface on the table is 0.15. You see, they even change the coefficient of friction there. Right, now we want to say, all right, we want to find out what the acceleration is on the block, right? And that's for 5 marks. Right, so what did we do? We said, okay, the first thing that we're going to do, let's start with, okay, so it means, okay, let me just redraw that so that you just remember. Okay, so we've got a 5 kg block now. We've got 2.5 kilograms. Okay, right, still on the table. Okay, so now let's look at this 5 kg block. What are the forces acting on it? Still the very same thing. So it's going to be the tension, it's going to be friction, okay, it's going to be the normal force as well as gravitational force. Okay, right, so nothing changes about that, right? So I know if this one accelerates downwards, so for this guy downwards is positive, right? So it means this one obviously would therefore go to the right, and going to the right would be positive for this guy. Ladies and gents, I think you've got the gist of it by now, right? So if I look at this, I'm going to say, okay, the tension is pulling in that direction. So it means for 5 kg, okay, it means that F net is equal to MA. I'm sure you got this. So it's going to be the tension minus friction, okay, which is equal to MA. But notice this, tension minus, remember, friction coefficient is 0.15 times the normal force. This time around, your normal force, that's 5 kg multiplied by 9.8. Again, it's not moving vertically, right? So it means that those forces are at equilibrium. So the normal force must be equal to gravitational force, right? And this is equal to MA, that's equal to 5 times A. So let me get that value there. So that's 0.15. Okay, let me just do it with you here. 0.15 times 5 times 9.8. Okay, 7.35. Okay, so that's T minus 7.35. And this is equal to 5A. That's equation 1. Okay. Right, once again, let's look at this one here. What are the forces that are acting on the 2.5 kilogram block? So there's our diagram. Okay, this is for, right, so it's going to be force of gravity. Now I think we had already calculated that. It was 24.5. Okay, since the mass hasn't changed. So that's 24.5 newtons, and then it's going to be the tension acting upwards. So this is going to be F net is equals to MA, right? Let me just make some space there. So this is going to be, if you note there, this is going to be, remember this guy is going downwards, right? So it's force of gravity. Okay, I'm taking that as positive. Remember, downwards is positive. Minus the tension is equals to MA. So that's 24.5 minus the tension is equals to 2.5 A. Now, let's call this equation 2. Okay, so that's 24.5. Sorry for that ugly writing there. Right, so this is going to be 24.5 minus T, and this is 2.5 A. And I think you now got the gist of it. You know what to do, right? So what we're simply going to do is take equation 1 plus equation 2, okay, and say T minus 7.35, okay, plus 24.5 minus T is equals to 5 plus 2.5, that's going to be 7.5A, right? And then obviously that's T minus T, that's going to cancel out, and you've got minus 7.35, okay, plus 24.5, okay, I'm getting an answer of 17.15 is equals to 7.5A, and of course you can divide both sides by 7.5, and your acceleration value there, right, should be equal to 7.5, okay, I get a value of 2.29 meters per second squared. Okay, right, so that's for that question there. All right, so you can try it out on your own. Just check if you do get the values correctly. All right, I think I want to kind of leave it there. Okay, so this would be our second lesson on Newton's laws. We're looking at pulleys, and then in our next lesson we're going to be tackling forces that are acting at an angle, right? So it means that we're going to be looking at systems whereby a force would be acting at an angle, okay, to the surface, okay, or to its motion. So in this case, we'll see just what to do on that question. As I said, ladies and gents, please don't forget, if you haven't subscribed already, please just hit that subscribe button, and please, by all means, this channel is just created so that it can assist you as much as possible in your matric year, or if you are upgrading, whatever the case may be, right? Please just remember, try and recommend it to as many people as possible so that we can help our people pass this subject called physical science. By the way, it's not really difficult, and for those of you who maybe are doing the subject again, or you are trying to improve your results, please remember, don't lose hope. Just keep working hard, and remember that there's nothing that you can't possibly achieve. Okay, so for my A students, I know that you are working very hard. All right, so just continue doing so until we meet again. All right, see ya. Sharp, sharp.